Alright, I thought I would post the solution to the group quiz problem from yesterday since most of you had trouble setting it up. So we're told that she rows 2 miles per hour and she walks at a rate of 3 miles per hour. And then we're asked where would she need to row to in order to minimize her travel time to the restaurant if she's 4 miles offshore and the restaurant is 6 miles downshore from her. Okay, so optimizing and our constraint. Okay, so we are minimizing her time traveled. And I gave you the hint on the board that you were going to need the relationship distance equals rate times time, which means that time, if you divide both sides by r, time is distance divided by rate. All right, well, her total time traveled is going to be her time spent walking plus her time spent rowing, right? So let's start labeling things here. We're going to need her distance walking and her distance rowing. So let's do this R for how far she's going to row. And then several of you labeled this as W for the distance that she was going to walk, which is fine. But then it makes this part of the triangle 6 minus W, which we did a problem like that in class. Since you're going to be using Pythagorean Theorem here, 6 minus W squared, it's going to give you some really messy algebra. So we're going to let this be W, so that when we set up our Pythagorean Theorem, this is much cleaner. And then this is going to be her actual distance that she's walking is then 6 minus W. So the time that she's going to spend traveling is the time she spends walking, which is distance that she walks, 6 minus W, divided by the rate at which she walks, which is 3, plus the time that she spends rowing, which is her distance that she rows, which is R, divided by the speed at which she rows, which is 2. So there's your function. Time equals distance over rate. Distance over rate. The constraint, most of you got, it's the Pythagorean theorem here that's set up within the problem. R squared equals 4 squared plus W squared. And then to solve for R, we take the square root of both sides. The negative root doesn't make sense. So we get that R is equal to the square root of 16 plus W squared. And then we're going to substitute that into the R in our time. Okay, so the function then that we're finding the minimum of is time equals 6 minus W over 3 plus the square root of 16 minus W squared over 2. What is our domain as far as what makes sense for W? Well, if W is 0, it means that she rows straight down to the closest point on the shore and then walks the entire 6 miles over. So W is greater than or equal to 0. And the greatest that W could be is she decides to row straight to the restaurant. W could be the entire 6 miles. So our domain is that W is going to be between 0 and 6. All right, so the derivative of time with respect to W, this is a little bit different because normally we're taking derivative with respect to time, but now we have time expressed in terms of distance. Let's see, the derivative here, the derivative of 6 over 3 is 0 because that's a constant, and then the derivative of negative W over 3 is negative 1/3, plus square root is a power of 1/2, so to take the derivative here, the 1/2 pulls down. We don't touch the inside. The new power is negative 1/2, and then we multiply by the derivative of the inside from the chain rule, which is negative 2W, and we're dividing by 2, which division by constants just pulls on through. All right, let's see if I got room right here down at the bottom to clean this up a little bit. So our derivative is negative 1/3. And then let's see, the 1/2 and the 2 are going to undo each other. And let's see, well, the negative exponent here is going to send this down to the denominator. So all we're going to have left up top is a W over 2 times the square root of 16 minus W squared. So there's our derivative. Negative 1/3 plus w over 2 times the square root of 16 minus w squared. All right, so I'm going to flip to a new piece of paper. Hopefully my focus stays, and we'll solve for where this is equal to 0. So negative 1/3 plus w over 2 times the square root 16. Ooh, hold on. I just spotted a mistake. Let's go back here. When I plugged in my constraint here, my plus sign changed to a minus sign. So these should all be pluses, which means, well, I kind of ignored the plus sign anyways. The derivative of the inside is a positive 2w. So yeah, all we're left with up top is a w. So I had the right thing, but I had a sign problem. There should be a plus on the inside. I don't know that it's going to make that big of a difference, but just in case. All right, so plus w squared. Where does this equal? Whoops, it's a little bit high. Where does that equal 0? Okay, when I've got two fractions, I might want to take one fraction over to the other side of the equation and then cross multiply to clear out my denominators. So if I add 1/3 over to the other side, now we can cross multiply to clear out denominators. So we get 3w equals 2 times the square root of 16 plus w squared. Everything is held over here, held by multiplication, over here, held by multiplication. So to get rid of the square root at this point, we can just square both sides. Square the 3, square the w. Again, you can do that because it's held by multiplication. So we get 9w squared. Square the 2, square the square root. So 2 squared is 4, and then when you square the square root, it goes away. Distribute the 4, so we get 9w squared equals, let's see, 4 times 16, I think is 64? Yeah, 64, whoops, 64 plus 4w squared. I have got w squared and a constant, so if I subtract the 4w squared over to the other side, we'll be able to essentially solve using the square root property. So we get 5w squared equals 64. Divide both sides by 5, and we get that w squared is 64 over 5. Take the square root of both sides, plus minus. We're talking about distances, so the negative doesn't make sense. So our critical number is square root of 64, which is 8, over square root of 5, which is just the square root of 5. You could rationalize that if you want. It's not necessary, but if you did rationalize it, that would simply be 8 square root of 5 over 5. So there's our critical number. Technically, you should go ahead and plug this into a first derivative test to check and make sure that you've got, what we're looking for, a min. If you plug 1 into the derivative, you're going to get a positive, and if you plug in 5 into the derivative, you get a negative. So, no, other way around, negative and then positive. So we're decreasing and then increasing. So it is a minimum. Anyways, okay, so going back to our picture, which we labeled like this, the triangle was the W, and the 6 minus W is how far away from the shore she lands from the restaurant. So that means where should she land on the shore, which is what the question asked. I believe, although let me double check. Yeah, at what point on the shore should she land to minimize her time? So 6 minus 8 over the square root of 5 gives us approximately 6 minus 8 divided by the square root of 5. It's about 2.42. So she should land about 2.42 miles from the restaurant. That will minimize her travel time.